This is section 3.2, solving systems of equations algebraically. Our objective today is I can solve a system of equations algebraically using substitution and elimination. The two methods that we're going to use are listed below. We're going to solve using systems of equations using substitution method and elimination method. For substitution method, we're going to solve one equation for the variables, substitute the expression from step 1 into the other equation to replace the variable, and solve the equation, and then substitute to solve for the other variable. In the elimination method, we're going to multiply one or both of the equations by a number to result in two equations that contain opposite terms. Then we're going to add the equations, eliminating one variable, and solve the equation. Lastly, we're going to substitute to solve for the other variable. In our first set of equations, a, b, and c, we're using the substitution method. So looking at example A, we have y equals 2x minus 10, and y also equals negative 4x plus 8. So, what we're going to do, we're going to take our first equation, which is y equals 2x minus 10, and since y is equal to that, that means in our second equation, where we have y, we can go ahead and plug in 2x minus 10 for that y value. So we have 2x minus 10 equals negative 4x plus 8. And then we can go ahead and solve for x, because now we don't have any y's left. So I'm going to go ahead and add 4x to both sides, so that I end up with 6x minus 10 equals 8. I'm going to add 10 to both sides, so that I have 6x equals 18, and then I'm going to divide by 6, which gives me x equals 3. Now that I have one variable, I can go ahead and substitute that variable into either one of the equations. I'm just going to choose the first one. So I have y equals 2 times 3 minus 10. So I'm going to end up with 6 minus 10, so y equals negative 4. So our solution is going to be 3, negative 4. On example B, we're going to do the same thing. However, we see that there's not one variable by itself. So we want to look for the variable that doesn't have a number in front of it. That's going to make it easier. And we can see that this x is by itself. So if I go ahead and subtract 5y from both sides here, I'm going to end up with the equation x equals 3 minus 5y. So now I have a variable by itself, and I can go ahead and plug what x is equal to, which is 3 minus 5y, into the x value in the second equation. So if I go ahead and do that, I'm going to have 3 parentheses 3 minus 5y minus 2y equals negative 8. So then I need to solve for y. I'm going to distribute so that I have 9 minus 5y, or excuse me, 9 minus 15y, because I have to distribute to both pieces, minus 2y equals negative 8. I can combine like terms so that I have 9 minus 17y equals negative 8. And then I'm going to go ahead and subtract 9 on both sides, so that I end up with negative 17y equals negative 17. I can divide by negative 17, so I end up with y equals 1. Then I can go ahead and plug that back in to one of the equations. I'm just going to plug it into the first one, so that I have x plus 5 times 1 equals 3. Then I'm going to subtract my 5 from both sides, because 5 times 1 is just 5, so I'll subtract 5 from both sides and get x equals negative 2. So our solution in this case is negative 2, 1. On the third example, we see that A is the piece that doesn't have a number. Now sometimes they'll all have numbers and you will have to solve, but in this case A doesn't have a number. So I'm going to go ahead and add 3b to both sides, so that I end up with a equals negative 22 plus 3b. Then in my second equation for a, I can plug in what I've got. So I have 4 times negative 22 plus 3b plus 2b equals negative 4. I'm going to go ahead and distribute to both pieces. And that's going to give me negative 88 plus 12b plus 2b equals negative 4. When I combine like terms, I'm going to have negative 88 plus 14b equals negative 4. I'll add 88 to both sides and end up with 14b equals 84. Then I'm going to divide by 14 on both sides. So I'm going to have b equals 6. I can go ahead and plug that back in. I'm going to plug it into my first equation. Doesn't matter which one I plug it into. And when I plug this in, I'm going to end up with a minus 18 equals negative 22. I'll add 18 to both sides. So a is going to be equal to negative 4. So our solution here is going to be negative 4, comma 6. In our second set of examples, we're going to use elimination. And the way that this works is that we need to add our equations down to get rid of a variable. In example A, we have 5x plus 3y equals negative 19, and 8x plus 3y equals negative 25. So I can go ahead and leave one of my equations the same on this one. I'm going to leave my first one. So 5x plus 3y equals negative 19. And then on the second equation, I'm going to multiply everything by negative 1. So I'm going to end up with negative 8x minus 3y equals positive 25. And what I'm trying to do is make sure that I have a positive and a negative of the same variable with the same number. So now that I have that, I'm going to go ahead and just add straight down. So if I add straight down here, I'm going to have 5 plus negative 8, which is just negative 3x. My 3y's are going to cancel because 3y minus 3y, or 3y plus negative 3y, is 0. And then negative 19 plus 25 is going to give me 6. I can divide by negative 3 on both sides, and x equals negative 2. Now that I have one variable, I can go ahead and plug it in. I'm just going to plug it into my first equation. So I have 5 times negative 2 plus 3y equals negative 19. I'll have negative 10 plus 3y equals negative 19. I'm going to add 10 to both sides. So I have 3y equals negative 9. I'll divide by 3, and y will be equal to negative 3. So my final solution is going to be negative 2, negative 3. On example B, what's really nice is that I already have a negative 3y and a positive 3y, so I can go ahead and just add straight down. 4x plus 2x is 6x, negative 3y plus 3y is 0, those cancel. And then we have negative 22 plus 16, which equals negative 6. I'll divide by 6, so x equals negative 1. And now I can plug that back into one of my original equations to solve for y. When I do that, I'll have negative 4 minus 3y equals negative 22. I'll add 4 to both sides. So I'll end up with negative 3y equals negative 18. I'll divide by negative 3 on both sides. So I end up with 6. Y equals 6. So my final solution here is going to be negative 1, comma 6. In the last example, I also need to get rid of something. Now, we can see in this case that I do have a negative 5y and a positive 5y. Now, we could multiply everything by a negative to get rid of something. However, I want to go ahead and show you guys a method in case no numbers in front of the variables match up. So if that is the case, what you're going to want to do, you're still going to need to multiply by something, What you'll do if we don't have anything that matches up, so if it wasn't negative 5y and negative 5y, the numbers were different, we would need to make some numbers the same. So what we would do, let's pretend like we're trying to get rid of the x's in this case. We would need to bring the 4 to the top, a 6 to the bottom, and then out of our 4 numbers here, one of them would need to be a negative. So I'm just going to make it a negative 4. And then I would need to distribute all the way through. So if I did that, I'm going to end up with negative 24 plus 20y equals 32. In the second equation, I'd end up with 24x minus 30y equals negative 72. And then I would need to add down. Here you can see that my x's are going to cancel. And then if we add 20 minus 30y, I'm going to end up with negative 10y equals negative 40. If I divide both sides by negative 10, I'll end up with y equals 4. Then I can go ahead and plug that back into one of my original equations. When I do that, I'm going to end up with 6x minus 20 equals negative 8. I'll add 20 to both sides. So I'll end up with 6x equals 12. Divide both sides by 6, so x equals 2, which means our final solution is 2, 4. Now sometimes with these you could get a no solution or an infinite number of solutions, and let's take a look at what that's going to look like. We're going to solve these using any method that we'd like. On the first one, I'm just going to go ahead and add straight down and see what happens. So I have 5x minus 5x, which is just going to be no x's. Those are going to cancel out. If I have 6y minus 6y, those will also cancel. So I'm just going to be left with 0 on this first side. And then if I add down on the other side, I'm going to end up with 83. And since 0 does not equal 83, this one is going to be a no solution. Let's take a look at B. So I need to come up with some method for getting rid of one. I'm going to go ahead and try elimination again on this one. So this is what I was talking about. Since neither one of these matches up, I need to get rid of one. Or I need to make them match up in order to get rid of one. So if I go ahead and multiply the top by negative 3, in this case I can just multiply 1 because I'm going to end up with negative 6x minus 9y equals negative 15 on top. And then I can leave my bottom the same. Now if you're not comfortable using this method, you can go ahead and bring a 6 up top and a 2 down below and then make one of them negative. That's okay. This is just a little bit simpler. But if you're more comfortable using the method where you bring the 2 down and bring the 6 up and then make one of those negatives, that's okay too. So going ahead and adding these, our 6's are going to cancel, our 9's are going to cancel, so we'll have 0, and then negative 15 plus 15 is also going to cancel, which means I'm going to get 0 equals 0. And in this case, that means that there's infinite solutions. So pretty much when you're looking at these, if you have two numbers, like in the first one, 0 equals 83, that don't equal, it's going to be a no solution. But if you have two numbers that do equal, it's going to be infinite solutions. The last type of problem we're going to look at is solving a system involving a linear equation and a quadratic equation. So, on the first example, we have y equals x minus 2 and y equals x squared plus x minus 6. We're going to use substitution here. So I'm going to take what y is equal to in the first one, which is x minus 2, and plug it in for y in the second one. So I'm going to end up with x minus 2 equals x squared plus x minus 6. And then I want to go ahead and get everything moved around. So I'm just going to go ahead and subtract x on both sides, and x's are going to cancel. So I'm going to have negative 2 equals x squared minus 6. And I want to get the x by itself, so I'm going to add 6 to both sides so that I end up with 4 equals x squared. To get rid of a squared, we're going to take the square root of both sides. So in this case, I'm going to end up with x equals positive 2 and negative 2, because remember when we take the square root, we have a positive value and a negative value. And so what we have to do here, that means we're going to have 2 points that we end up with in the end. We're going to have to plug both of these into one of the original equations. So first I'm going to have y equals 2 minus 2, which is 0. So my first solution is going to be 2 comma 0. And then when I plug it into the second one, I'm going to have y equals negative 2 minus 2, which is negative 4. So my second solution is negative 2 comma negative 4. Let's go ahead and do the second one. Again, since y is equal to 2x minus 4, I can go ahead and take that value and plug it in for the y up top. So I'm going to have 2x minus 4 plugged in for my y equals x squared plus 2x minus 13. And remember, I want to get my x's, I want to get my x squared value alone. So I'm going to go ahead, I'm going to subtract 2x from both sides. Those are going to cancel. I'm going to go ahead and add 13 to both sides. So I'm going to end up with 9 equals x squared. And remember, to get rid of the squared, we're going to take the square root of both sides, which is going to give us x equals 3 and negative 3. So then I have to plug both of those values in. So for the first one, I'm going to have y equals 2 times 3 minus 4, which is 6 minus 4, which is 2. So my first value is 3 comma 2. And then secondly, I have to plug it in again. So I'm going to have y equals 2 times negative 3 minus 4, which is negative 6 minus 4, which equals negative 10. So my second value is going to be negative 3, negative 10.